In today's lesson, we'll be discussing section 9.6, which will be about solving rational equations and inequalities. Our target will be to solve rational equations and inequalities using algebraic techniques. We're going to start with solving. Okay, there's a couple different scenarios when you're solving rational equations. Again, rational meaning that you have expressions in both the numerator and the denominator. First thing we need to discuss is when values should be excluded from your solution set. Okay, when you're solving a rational equation, it is possible to solve and get values of x that could make a denominator equal to 0. Okay, and we know we cannot divide by 0. So looking at these two expressions, you look at the denominators. Okay, you look at what values of x would make either one of these denominators equal to 0. There is only one. X cannot equal 1. So that means if we solve this and we end up getting a value of 1 for x, that solution needs to be excluded. Okay, and there is possibility of having no solution. Okay, now looking at this just generally to solve, there's a couple different scenarios that we're going to look at. One is involving this scenario when you have a rational expression equal to a rational expression, basically a fraction equal to a fraction. We have no fancy techniques in this case. Okay, basically treat it as a proportion, and we will cross multiply and solve. Okay. So we've already discussed that we looked at the denominator, and the value that would make it 0 is 1. So then that answer of 1 would need to be excluded. Just discussed also that we have these two fractions that are equal to one another. So in other words, this is a proportion, and we're going to cross multiply to solve. So when we cross multiply, the 4 gets multiplied by the 12, the x minus 1 gets multiplied by the x plus 1. You would want to FOIL that. It is going to be 48 equals x squared minus 1. We only have an x squared term, so we can just go ahead and add the 1 to both sides, then square root both sides. And again, do not forget when you square root to solve, you need a plus or minus. So our answers are plus and minus 7. And again, you need to remind yourself, what values did we exclude? We excluded 1. Plus and minus 7 is not 1, so plus or minus 7 are our solutions. Nothing needs to be excluded. In this second example, we don't have a proportion. Okay, we have a rational expression where we do not have fractions on both sides. So what we're going to want to do is we're going to want to combine those into one fraction, or just eliminate the fractions completely by looking at all the denominators and multiplying by the least common multiple. First thing, always look to see if anything can be excluded. Okay. No values are excluded because the denominator is going to constantly be 5 and constantly be 3. No value of x will ever make the denominator equal to 0. So there are no excluded values to this solution. And what method should we use to solve? Okay. Should we add the fractions on the left side, combine them? Should we make a proportion out of this? Okay. I'm a fan of looking at the least common denominator, least common multiple of the denominators, and multiplying every term of the expression by that least common denominator. Okay. So you see, the least common denominator is 15. So what we're going to do is we're going to multiply every term by just 15, not 15 over 15, just 15. Okay, and let's see what happens with that. All right, so when we multiply each expression by 15, each term by 15, 5 goes into 15 3 times. 3 goes into 15 5 times. That 3 is going to be distributed. That 5 is going to get distributed. And now it's just 15 times 1. What that does, multiplying by the least common denominator, allows us to eliminate all the fractions. And now we no longer have fractions to work with. Okay, you see the 3 being distributed to the 4x minus 3. And you see the minus 5 times the 4 minus 2x. And now it's equal to 15. Okay, and now we distribute and solve. Okay, we got 12x minus 9 minus 20 plus 10x equals 15. Simplify and solve. And we have an answer of 2. Again, no solutions were excluded, so 2 is our solution. We're going to solve these. This type of problem will be more similar to the problems that we're going to see throughout this section, okay, where we have each term has its own rational denominator. We have to look at what we can exclude. You have two basic denominators going on here. You have x minus 2 and x plus 2. So what we need to exclude is we need to exclude 2 and negative 2. So if we get an answer of 2 or negative 2 as our final solution, we will exclude that value. The least common denominator between these two values is x plus 2, x minus 2. So our technique is going to be to multiply every term by x plus 2, x minus 2. Not over itself, just over 1. So it's going to look like this. Okay, first term multiplied by x plus 2, x minus 2. Second term multiplied by x plus 2, x minus 2. And third term multiplied by x plus 2, x minus 2. Again, why we're doing this is multiplying every term by the least common denominator will eliminate every fraction. Okay? The x plus 2's cancel out, the x minus 2's cancel out in the second terms, and the x minus 2's cancel out across the equal sign. Okay, so now it's looking like this. You have your x times x minus 2 minus your x plus 2 times another x plus 2. And then you have this x plus 3 times x plus 2. What we just need to do is do some foiling, do some simplifying, and we'll have our answer. We're distributing. Okay. We have a FOIL here, x squared plus 4x plus 4, but the negative sign needs to be distributed, so that's how we get those terms. And then we FOIL here. Combine your like terms. Looks like we have a quadratic, so we get that quadratic equal to 0. This is factorable. Set each factor equal to 0 and solve. You get 10 and negative 10 and negative 1. Neither of those answers are excluded, so those are your two answers. I'd like you to try these two examples for class, and we will work through these two examples in class tomorrow. The next thing we will be doing in this section is solving rational inequalities. You're going to have to watch carefully here. It's going to seem a little strange, the techniques that we use in order to solve this algebraically. So please just pay attention to these first few examples. Okay. There is only one fraction, so the least common denominator is x minus 5. We do want to express that. Okay. What we want to do in order to solve a rational inequality is to get one side of the inequality equal to 0. It doesn't matter which side. In this case, the easiest side is just subtract the 3 and get that right-hand side of the inequality equal to 0. Okay, now, why we do this is to be able to create a single fraction. So we are going to combine these two values now to create a single fraction with a 0 on one side. So to make that single fraction, we have to have a common denominator. So we are multiplying by x minus 5 over x minus 5 to that term. Okay, leading us to here. We have 2x minus 7 over x minus 5 minus 3x minus 15 over x minus 5. It is less than or equal to 0, so combining it now. Okay, we have negative x plus 8 over x minus 5 less than or equal to 0. Okay, that's our starting point. Again, I'll re-emphasize the points. Get one side of the inequality to 0, doesn't matter which side, combine the other side into a single fraction. Okay, once we've done that now, we are going to identify the numerator denominator zeros and the denominator zeros. Okay, meaning we're going to identify what values of x will make the numerator equal to 0 and what values of x will make the denominator equal to 0. 8 will make the numerator equal to 0. 5 in this case will make the denominator equal to 0. What these numbers end up being is they end up being critical points on a number line. We're going to use a number line in order to describe our solution. So we input the 5 and the 8 in the correct order on the number line. The numerator denominator will follow, in terms of open closed circle, will follow the inequality symbol. So you see it's a closed circle on the 8. The denominator 0 will always have an open circle because you cannot have 5 as part of any solution. 5 would make the denominator 0. It is not part of the solution at all. So you see an open circle on the 5. Okay. See these critical points, divide the number line into 3 regions. what we're going to do now is take a number out of each region, test it into our inequality, and see if it makes it true or false. Okay, so examples. We're going to take x equals 4, and we're going to input it into the inequality. 2 times 4 minus 7 over 4 minus 5. It's supposed to be less than 3. Okay, we're going to take a value of, say, 6 in the middle. Okay, 2 times 6 minus 7 over 6 minus 5 less than or equal to 3. And then over here we could take 9. 2 times 9 minus 7 over 9 minus 5 has to be less than or equal to 3. We're going to decide which regions are true, which regions are false. Okay. When we put in a number 4, okay, if you did the work, the inequality was true. That means it is true in this direction. Okay, when we put in 6, the inequality was false. That means we do not shade in the middle. Those numbers in between 5 and 8 do not make the inequality true. And then x equals 9, the inequality was true. So we shade that side. What this looks like to me is an OR statement. We have a disjunction. It is an OR statement. So now we describe our inequality based upon this graph. Okay, x is less than 5 or x is greater than or equal to 8. You do need to be careful with these. You can get some very atypical graphs, and you do need to graph the regions and just see what happens. Let's try this example. Again, follow the same steps. We are going to get one side of the inequality to equal 0. Done. Concentrating right here. Now we're combining these two fractions to get them into one fraction. So we need a common denominator. The first term will have to get multiplied by t over t. The second term will have to get multiplied by 2t plus 1 over 2t plus 1, creating 9t over, probably should have just written that as t times 2t plus 1, okay, and then 10t plus 5 over t times 2t plus 1. Okay, it's the same thing. Okay. Combining the fractions, we get negative 1t minus 5 over the common denominator of 2t squared plus t or t times 2t plus 1. Either case is fine. Okay. So now after we have these values, okay, again, what we do after we get one side to 0, doesn't matter what side, and then we get the expressions combined into one fraction like we have here, now we identify what values make the numerator 0 and what values make the denominator 0. Okay. So the critical points, the values that make the numerator 0, okay, is negative 5. Okay, the values that make the denominator 0 are 0 and 1 negative 1/2. Okay, these are 3 critical points onto our number line. Now the numerator 0 follows the inequality symbol, so the numerator 0 will have an open circle because of the inequality symbol. And again, the denominator zeros are automatically open circles because they are not a part of your solution at all. Okay. Now we have 4 regions to test. 1, 2, 3, 4. We have 4 regions to test. Okay, we need to test these regions and decide the truth value of these. So you pick a number less than negative 5, like negative 6. You can take the time, plug it in, see whether it's true or false. In this case, it is true. Okay, we have negative 2. Negative 2 falls in region 2, in between negative 5 and negative 1/2. It's false. We do not shade that region. The region between 1/2 and 0 is not very big. We have to pick an actual fraction itself. I have to pick negative 1/4. Okay, when I check that, that region is true. Okay. And the last region I have is greater than 0, okay, and that is a false. When you plug it in, it is false. Okay, so these regions were true. The other 2 regions were false. So you see where the shading is. Now we need to describe this inequality. Okay, again, these can be very atypical. This is a disjunction. To the left, you have t is less than 5. Excuse me, t is less than negative 5, or the description of this region is an and statement. Negative 1/2 greater than t, negative 1/2 less than t less than 0. And that is our final solution based upon this graph. Okay, I will would like you to try this example for class tomorrow, and we can go through it in class. And also, okay, so we have 3 examples to go through in class tomorrow. We have 2 solving irrational equations, and this one solving this rational inequality.